Hi everybody, today I wanted to show you a solution I found to a problem that I encountered recently. I'm hacking a toy telephone as a silly little project to be able to control it via MIDI, so I can play it with a keyboard. But I also wanted to be able to control the volume with the velocity of the keyboard. If you don't know what those things mean, basically it means that I want the toy phone to sound louder if I hit my keys harder. So I wanted to do that with the Arduino, but the problem is that apparently that wasn't as simple as I thought. Now, I'll quickly tell you about the tools I'm using here, and then I'll show you how I'm going to do this. So I'm using the Moog Werkstatt as a synthesizer, as an audio source for this demonstration. I'm using the Casper Electronics Omsynth, which I'm going to use only as an audio out, so it's just an easy way to turn what I'm doing into audio that can go to my mixer. And I'll just demonstrate what the basic sound is. So if I connect the VCO out, the oscillator of the synthesizer, to the audio out of the Omsynth, then I get this. Alright. And the last thing I'm using, of course, is the Arduino Uno. Now, controlling the audio volume in an analog circuit is really easy. What you do is you connect your audio source to a potentiometer, which is a resistor that you can vary. You connect the other side of your potentiometer to the ground of your circuit, and then you can connect the middle pin of your potentiometer to the mixer, and you get this knob that you can turn to change the volume. So that's easy. Now the question is, how can we make the Arduino do this? And that is not so easy, because the Arduino only has digital outputs. So the outputs are either high or low, with nothing in between. But some of the outputs, on this model it's 3, 5, 6, 9, 10 and 11, can do pulse width modulation. And what that is you get a pulse wave when it goes up and down, but you can vary how much of the time it is up versus how much of the time it is down. The frequency stays the same, but the proportion of up signal to down signal changes. And I can demonstrate that with this Arduino sketch. As you can see, this is a very simple sketch. I'm only using the loop function, and in that loop function I'm doing basically two things. I set the 9 pin to a high pulse width, then I wait for 2 seconds, or 2000 milliseconds, and then I set it to 0, so a very low pulse width. And then I wait another 2 seconds, and then I start again. Using that Arduino sketch, I can now use my pin 9 to power an LED, which is this one here. I'll put in a resistor to protect my LED. And connect the other side of the LED to ground. And as you can see, it now goes off and on, which is rather simple to do with digital pins. But what I can also do now is use values between just off and on. So if I change my 0 in my sketch to 128, then you'll see that my LED goes brighter and less bright every 2 seconds. Now, how can we use this to control the volume of our audio? Well, there is a trick that has been used in synthesizers for quite a while called a vactrol. And a vactrol is basically a light-dependent resistor which you use together with an LED. So the principle is very simple. We go back to using a resistor on our audio. So from our oscillator through the light-dependent resistor to our audio out, we get our signal. And now if we make it dark around the resistor, the signal goes down. Now, we're basically done here, because what we need to do now is just put in the light dependent resistor next to the LED. And send our audio through there. If we make it dark around the resistor, you'll see that the volume varies depending on how bright the LED is. Now, a more convenient way of doing this with an LED and a light dependent resistor, where you need to cup the resistor to get an effect, is to take a light dependent resistor and an LED, put them head to head, put heat shrink tubing around it, and then you get this. And this is a homemade vactrol that I made. And inside this, you get the LED and the light dependent resistor in a dark enclosure, which means you don't have to put your hands over it anymore. And if you have fingers that aren't as fat as mine, so you don't struggle with wires. You can hear that the volume is changing even if I'm not cupping the light dependent resistor anymore. So now I've got a Arduino controlled volume control of my audio, and I can start doing other things with it. Now that I have this in place, I've got my hands free to do something else. So with a different Arduino sketch, like this one, I can create a rhythm. And then I can start playing my synthesizer. Okay, so that's it. That is Arduino controlled volume control in an analog audio circuit. Thanks for watching, and if you have any questions, leave them in the comments below.